All right, I got a couple questions about the worksheet for Monday, and I was asked to go ahead and post a video explaining a couple of the problems that were the toughest. And so I'm going to do some of those now, but I want to remind you about a couple things first. Um, if you remember the rules from Thursday, we had adding and subtracting integers, and we listed out some of the rules for doing that. If you're adding uh, like signs, if the signs are the same, positive plus positive is a bigger positive, and that's the same thing for the negatives. So those are the things that we went over on Thursday. Then we talked about subtraction and how subtraction is adding the opposite if you need to do that. And for example, in this case, we had minus or the opposite of 3, negative 3, subtract 4 or minus 4. And instead of writing minus 4, we can change it to an addition problem, and that makes it look a little bit different, right? In this case, I was visiting with an adult earlier today that said they were explaining to their child about it, and they said, like, think of a board game such as Monopoly or Life, and if you owe someone $3 and you have to give them four more dollars, then you've got a compounding negative situation there. So you've got negative 3 and negative 4, which would make negative 7. You add those two digits together. Even though there's a subtraction sign, those numbers are being added. Okay, so that's some of the trick behind adding and subtracting. Multiplying, we looked at it this way, where we had these rules: the two negatives make a positive. That's what you hear a lot in multiplying and dividing fractions. The quick way to remember it is if both the signs are the same, then it's positive. If they're different, then it's negative. In math class, we talked about this when we were doing some math minutes, about the case that when you have two numbers being multiplied to get or divided to get a third number, there's always two negatives in the problem. If there's one negative, there needs to be another negative. If there's all positives, you don't have to worry about it. You've been doing those problems since third grade. But if you have one negative in the problem, there's got to be another one to pair off with. Sometimes it's in the answer. Sometimes they're both in the problem. Okay, so that's a quick review of the questions. This is the worksheet we're going to be working with on Monday. This is addition, subtraction, multiplication, division. On the front side, we're doing the review with the rules written right there as the instructions. And then on the back side, they're all mixed together. So you have to do some sign watching. You really got to watch to see that you're getting the right sign applied to this. So what I mean by that, let's look at this first one. You have an asterisk, which in the world of typing, that's often used as a multiplication symbol. That's that dot between the two numbers. So this would be negative 5 times negative 3. This one over here, you've got an adding, and you're adding a negative number. It's in the parentheses to separate that negative to make it separate than your addition sign. You don't need it, but it is helpful to do that. This one's just simple subtraction, 6 minus 13, but it is subtraction. And this one over here, which if you look at 35 and 36 together, they're awful closely. They look pretty much the same. In fact, if you didn't know about integers right now and you look at this problem as a fourth grader, you would say that's 11 minus 6, and you'd ask why there's parentheses. But in this case, you've got the background this year to tell you that that's a multiplication problem. You've got one number set with right next to another number. They're separated by parentheses, and that's multiplication, 11 times negative 6. Okay, so that there's some little trickiness here. This is all about how it's written, and this assignment is helping you get used to that, because you're going to see a lot of this in algebra problems. This one, you're going to see one very similar to that, where they're going to be demonstrating the distributive property, and we got to make sure that we know how to do that in sixth grade, so that when you do that in seventh and eighth grade, you're not hit by such a confusing thing. Some of you will forget, and you'll need to be reminded in 7th and 8th grade, but do me a favor, don't say, Mr. Nelson never taught us that, because I'll pull this paper out and say, yeah, right there. Okay, so let's do a couple of these example problems. These were 4 that were sent to me as some ones that the kids were having trouble with. So we're going to start with this one, with a couple of the easier ones, and then we'll work down through the harder ones. Number 2 is like -21. So remember, there's different ways to look at negatives. You can call them good guys and bad guys. You can think about money or temperature or whatever. But because I used the example earlier of the adult that I was talking with, and how he said that he thought about it as money, like in a board game, we're going to use that example here too. So if you land on someone's property in Monopoly, you have to pay them a certain amount of money. Let's say you land on one and it charges you $21. So you're going to have to pay $21. If you're playing the rules right, you pay right then, and you get that taken care of, and then you pass the dice to the next person. But sometimes, if you have a really nice brother or sister, they let it slide, and then you pay them on the next time after you pass go or get some money or something like that. So in this case, you've got owing $21. You roll ahead and you land on the next space. So how much money do you owe altogether? Well, the owe part, how much you owe, is the negative. That's taking it out of your account. So that's like a subtraction from your account. In this case, though, you're adding those two values together. So it's $21 and $11, which makes 32. So you can see that you're using the negative sign as an indicator to how that $32 is being spent. You have $32 in your account. You regularly, in your bank account, you would just call that $32. You wouldn't say negative $32. But if you owed $32 or you spent $32 more than you had in your account, that would definitely be a negative. And so that's why we use negatives to represent numbers in the real world. Here on number 11, again, there's these parentheses, and that's just meant to keep the -7 as its own quantity by itself. So -7's over here, but you're going to be subtracting that. So these are harder to relate to the real world, or even a board game or something. But here's my attempt: is if it's -7, that's like you owe $7, right? So you have to account for that at some point. But you could possibly have that erased and not have to worry about it, which would make these two a positive, right? Or it's the opposite of owing $7, which means you're getting $7 back. So this is that little trick where you've got the two negatives together, and in this case, it's a subtraction problem, but two negatives do make a positive because they're canceling each other out. You're subtracting the opposite. Now, if you remember last week, I did this little funny looking guy. Whenever you see that face, then you can turn him positive, and that works out pretty good. 13 plus 7, pretty easy problem at that point, all right? And it's going to be positive because both of those numbers are positive. All right, those were fairly straightforward. We're going to move down to 44 and 47 here. 44 is written this way in your homework. This symbol right here is just it's a backslash, and it is indicating division. So if we wanted to rewrite it, we could write it like 360 divided by -36 divided by -2. So you've got 3 separate quantities here, 3 separate numbers, and they're being divided. Well, remember your rules of operation. You have to work left to right. And so you're going to start here, 360, which is a big number, divided by -36. But we helped you out a little bit. It's 36 and 36. In this case, it's division, so it's 10. 10 is our answer between these two numbers here. So we're going to write that there. But I ignored the negative sign, which in this case we can just go back and look. Remember, there's positive, negative, and when you have a positive divided by a negative, you have a negative answer. All right, but we still got this part of the problem to deal with. So I'm just going to write that down here. The hovercam's having a lot of lag today, so I hope that's not messing you up too much. You've got two negatives this time, and it's going to be 10 divided by 2, which is 5, but the two negatives are already in the problem. They cancel each other out. You're going to have a positive 5. So there's that answer. 47. This is another one of those. Is that a subtraction sign? Is that a negative? That's what the student, I think, that had trouble with this was thinking is, I don't know whether that's a negative or a subtraction sign. Well, actually, it doesn't matter. These two quantities, negative 18 and negative 33, are being combined. If it had parentheses around it and it was snuggled up next to there, then you would call that multiplication. But in this case, it's two negatives, or that's a subtraction sign, and that means exactly the same thing. So remember our rule for subtraction? We'll add the opposite. That'll make this problem look a little bit easier to you, I think. So we're going to start with the negative 18. Nothing changes about that. But instead of subtraction, we're going to add the opposite of 33. So now it looks like a much simpler problem. You've got negative 18, 18 bad guys, and you've got negative 33, which is 33 bad guys. Negative plus a negative, bigger negative. Okay, 3 plus 8, that's 11. You actually could carry a 1 there. 3, 5. Your answer should be negative 51. Okay, to me, the hardest part about that is setting up the signs in here, making sure that that subtraction becomes an add the opposite, right? Actually, that to me is easier than the arithmetic. 18 plus 33, I had to think about that one just a little bit. So there we go with those 4. Okay, there's a couple more down the page. Nobody asked me about these yet, but I'm feeling like those are going to be some that hit you pretty hard. One thing is we haven't reviewed exponents for a while, and we probably, there were a couple in your math minutes, so you might have done that. On number 53, we're going to look at the 5 squared. That's the exponent. So 5 squared is 25. 5 times 5, right? That's what that little squared button is. And you're going to add negative 15. Once you get that exponent out of there, it looks like it's going to be a lot easier problem. So this is basically 25, negative 15, or if you want to do the reverse of what we just did, it's 25 minus 15. That problem you can solve pretty quick in your head, right? Okay. Let's go to 56. Negative 1. You've got an exponent of 234. Now this looks like an evil problem. If you had to write this out, you would start with negative 1 times negative 1 times negative 1 times negative 1, and you would go 234 times to do that. But this is a special case. Remember, when you have two negatives, they end up being positive. Two more negatives, positive, and you're going to have 1 times 1, and you're going to equal a positive number, right? The thing is, when you write these out, you're going to have 234. 234 is an even number. That means for every negative, there's a partner. They're going to be paired up, and they're going to cancel out. That means at the end of 234 negative ones times each other, you're going to definitely have a positive, and it's going to be 1 times 1, which is 1, so you're going to have a positive 1. Okay? If that number was odd, there would be 1 left out. There'd be 1 odd man out, and so that would be left as a negative. It wouldn't be paired off to cancel out. So if you see a negative on there, which I don't think there is on this one, then your answer is a negative 1. In this case, it's positive because they're being paired up. All right? Be sure to email me if you have any more questions, and watch the video tomorrow.